Okay, yeah, welcome to Madara Community Call number 5. So let me share my screen. I will share the agenda for the call. So as usual, we will start by a backlog review and the task update by the different contributors. Then Terence will do an update about Dojo and Cartridge and something exciting he started to build. Then Matthias will do an announcement about the Starknet Hackathon and specifically about the Madara track for this hackathon. Then we'll talk a bit more about the roadmap and the next steps and milestones for Madara. And then Ben will do a deep dive on one RPC implementation, which is a very important one, Starknet add invoke transaction that enabled users to submit transactions to the sequencer. Okay, so let's start with a backlog review and the round table. So yeah, Matthias, you want to start?
Yes, sure. So I've been finishing up a PR that's not here, but basically to so all the types in the runtime are going to be switched to something more aligned with the Caro VM, so a field element wrapper. So it's taking me a bit more time than expected because I need to change everything. Yeah, but once this is here, we won't have to do these painful conversions of types that we do all the time in the code base. And so it will be less prone to error. It will be, yeah, we'll just be better. So more efficient, less prone to error. And yeah, so that's the first thing. And then there is the declare transaction to declare smart contracts. So this will be as soon as I've finished changing these types. I've already done it. I just need to fix a few things, and it's also related to an issue we have with the contract class between Caro 0 and Caro 1. So it's a pretty hard type to handle, and I think there is someone on it already.
Okay, good. Timothée, you want to go next?
Yes, so for the past week, I've been mainly focused on building a light implementation of the Tendermint consensus algorithm for Substrate. In Substrate, the way it's built right now, maybe you saw it in the code base, block production and the block finalization are done asynchronously. So different blocks are produced, and once in a while, there is a quorum of validators that decide which is the longest chain and the official chain, and it gets finalized. So at this point, we are sure that those transactions won't revert. But for Starknet, because of like the wall proof mechanism and commitment on layer 1, we would really much like to have instant finality. And one simple, I put it some quote, but simple algorithm that provide an instant finality for consensus is Tendermint. Is a consensus algorithm used by the Cosmos ecosystem. It was a huge breakthrough in terms of consensus when it was a proof of stake consensus when it was released, but there is no implementation of it in Substrate, non-production ready. So I found one which is in Rust, and I'm trying to make it compatible with Substrate itself. So I have my code. Now I want to have some tests. Just right now, it's just like the core engine, having the core engine of the protocol, of the consensus protocol work. And then I will try to have it used by a Substrate node. And the reason why we are doing this is because there is like two possible different future for Madara. One could be to become like one, if not like the official implementation of the Starknet network, so the layer 2 itself. But there is also a lot of projects that want it as a layer 3 for application-specific blockchain. And for the first one of this future, being like the core Starknet engine, we would need to have a Tendermint. So we are doing a proof of concept of this so that Starkware team can look at it and take a decision regarding this.
Thank you very much. Greg, you want to go next?
Yeah, sure. So finished yesterday and got merged with the deploy count transaction. Also uncommented some of the skipped tests, which I think was merged this morning. I could, if needed, add maybe more test coverage for the for both of the add deploy and add invoke transactions. I'm not sure if it's needed. Otherwise, right now, starting on the parameterization for the hashing on the RPC side to try to match it with either make it configurable or match it with the hasher we're using in the runtime.
Awesome.
Okay, very cool. Yeah. Timothée, do you know if it is usual to get some trait implementation from the runtime in the client side? Like, let's say we want to, instead of having two different configurations that could be conflicting, one of the, let's say, for example, on the client, you configure Poseidon, and on the runtime, you configure Pedersen. That will be a problem. So can we, I don't know, maybe in the runtime API, return the implementation of the hasher trait from the palette directly and get it in the client? No, you don't see what I mean?
No, not really. What will be it will be a dependency problem?
No, it would just not work, for example. Let's say in the RPC, in the client side, you want to use to do some hash to hash on data, but you want to be compatible with what is defined on the runtime.
I think, yeah, I don't know if we could remove all the hashing from the client side and do it everything in the runtime with the so that it always uses the same implementation. Because
Yes.
otherwise, I don't see any better way to do it.
Could you return a hasher type during the server, the RPC server in this load up, and just return a hasher? Add that to the Starknet server or not?
Probably that's possible. Yeah.
Okay, let's try to think about it. Okay, never mind. Thank you, Greg. Sparket or Sparky, I don't know how to pronounce it.
Yes.
Okay. You want to give an update or?
Oh yes. I did the get transaction by index and the ID RPC endpoint.
Okay.
And there is a bug in the test in the file test. We can't do two transactions in the same in the same file test. You see here, I added a transfer. Okay, and there is another test. I think it's get transaction by hash. It's no, it's in the same file.
Okay.
He he also do transfer. Yes, he just up. Yes, here.
Okay. Yes, here. Okay.
He did the transfer. It works for him, and it doesn't work for me. But when I comment his test, it works for me.
Oh,
Yes, I've been looking into it and I can't find the
tests
fix.
are run sequentially, right? They are not running parallel.
Yes.
Yeah,
Sequentially, yes.
supposed to, yeah.
Okay, that's weird.
I-
Yeah.
Is the nonce hard coded?
Oh,
I think that might be a nonce problem. Yeah.
oh, good point, Ben. Yeah, it might be a nonce issue indeed. If the nonce is hard coded, yeah, it's normal that it passes on the first one that will do it actually. Yeah, good point, Ben. It might be that. So yeah, Starknet, if you want to have a look, it might be a problem of the nonce. And to solve that, we will need to have a static value for the nonce and increment it during each test.
Mhm.
And use it
we
might be
start
that.
from 0 and we increment it one by one. Okay.
Okay,
Okay. Yeah.
good. Thank you. Thanks for the update. Ben?
Yeah. So do you want me to give an update or to go through the code?
The
for
update
add?
first. Yeah, the update only, and then
Okay. Added the endpoint for add invoke transaction. And updated some of the hurls to reflect the testing of that. And then included some integration tests for add invoke transaction. One of the things that Greg and OX Evolve found is that the runtime API exposure is only read, not write. So that's going to help me implement estimate fee. So estimate fee I'm working on now. I should have it by end of day today.
Yeah, but
Okay.
still there was this problem of how do you get the data back from an extrinsic call, because an extrinsic only returns substrate data and you cannot get the return data. So I don't know, Greg, what ways did you find about this, or just using the parameters you had, but I think you didn't find some way to get back this data.
Yeah, the way I did it for transaction hash, because I just needed transaction hash and deployed account contract address, and that was just calculated when converting the deploy account transaction to a transaction. So I never really had to get anything from the extrinsic. For
the fees, Ben, you might have to get that after execution. So I don't know if you struggle into that, but I think it will be I don't know, Timothée, if you know.
But since it's not a write, the way I'm doing it right now is I'm actually executing and then getting the call info back, and then the call info has the fee that I'm passing back from the runtime API.
Okay, because I thought the call info was the substrate call info.
I'm converting it to a U64.
Okay. Well, we need to check that.
okay, cool. Glim?
Yes, sorry. I was late. I started the first implementation, but then I just missed time. I had a call with Timothée to understand a bit better some stuff and the mapping, because for transaction we have to index the transaction to have an efficient lookup. So today I will go into this, and if I'm really stuck, I will just ping on GitHub. But I'm very sorry, I just late on the delivery. Sorry.
No worries. Thank you very much. Okay, Lana, maybe?
Oh, yeah. Hi everyone. Nice nice to see you.
Yeah, nice to meet you.
Oh, yeah. I just picked up a good first issue, and we decided not to, I guess, move forward with it because the way it was designed is because you have something in primitives that was suggested to be dependent, something in the runtime config, and it was just creating some circular dependencies in that regard, because it was a bounded vec pulling the length from the runtime config. So I either suggested like to create another crate, or like a commons crate for things that could like point from primitives, but I figured like that you want to leave it as this, but I'll just find another good first issue then. Thank you.
Yeah, thank you very much. Yeah, as a general comment, we need to create more good first issues. It's been we were focused on the different RPCM implementations, but now we need to create more good first issues. So we'll try to do that soon, and I will update you on GitHub and on the Telegram group for people that want to tackle good first issues. Okay, Robin, maybe.
Hi. So yeah, I was supposed to work on the get transaction receipt endpoint, and I was just basically aimlessly waiting for Glim to close his PR so he could copy his homeworks, because the PRs are basically twins, and both him and I got caught up with time, so we're hoping to be able to work on it this weekend. Or else we will find another way to quickly close up those tasks.
Okay, nice, thank you. Okay, is there anyone I missed who want to do an update? Otherwise, we can move to the next item in the agenda. Let me know if I forgot you, and I will give you the opportunity to speak. Okay, so Terence, if you want to give an update on Dojo and Cartridge and what you are building.
Definitely. Hey guys, yeah, so the Dojo project continues to make good progress. A big blocker for us has been the ability to deploy the world. So Dojo is an engine for building on-chain games and autonomous worlds on top of Starknet. It's using a newer version of Cairo, so it's incompatible with testnets right now. And I think like is a great Madara and layer 3s are going to be a great target for on-chain games. So super excited to be able to deploy Dojo worlds there soon. We've made a lot of progress on the Dojo project side. And the main blocker has been the ability to deploy things and test them end to end. We have tooling for like a higher level like representation of a world's architecture using an entity component system that's pretty much solidified. We've been working on the networking stack, basically like an indexer that will automatically. So with the Dojo world, you can dynamically install systems and components. So like this, the idea is this, on-chain universe can be permissionally expanded by people. So people can add new logic to the game or new state to the game. We have like a networking stack that helps synchronize what's happening on the blockchain or the sequencer with the client automatically. And that's making good progress. And we have a bunch of tools. One of the other things we've been working on is Katana, which is a development node, which I think is like very similar progress to you guys on Madara. Mostly waiting for Blockifier to support Cairo 1 execution, which I think is maybe like basically there. As Sahar was saying, just like we're missing Kechek, and that's it. So
yeah,
good to go.
It's like very close. I think next week we'll be able to have it, or the week after.
Cool. So yeah, we're moving now in the dojo to the phase of trying to get people building on top of it. We have a few different games. Like the Realms team is using it. We're building a game on top of it for Dope Wars. The Influence team is using it, and there's another team that's starting to get onboarded to the stack. And yeah, as part of that, next week we have actually an on-chain gaming conference in Lisbon that we're going to be presenting Dojo and Madara as part of like this package, like the Stark stack or whatever, of like how you want to build how Starknet and can enable these types of games on chain. So excited to present that. And then in line with that, at Cartridge. So Cartridge is a company I founded about a year ago now. And we're building infrastructure for on-chain games. And we've been working on a one-click like sequencer deployment platform to support the deployment of Madara sequences into our Kubernetes cluster. And I can share what that looks like. It's quite simple. It's basically, let me see if I can
please share. This is very exciting. I'm very excited about that.
Share my screen.
Yeah.
Okay, give me one
please.
second. Yeah, I mean, it's quite simple. Like basically the initial version, at least, you can, inside of the UI, these are the UI, the backend's mostly there. We just need to spend some time on the front end, looking at like implementing this UI, which is probably like a week of effort or so. But yeah, we have like the deployer screen. You can create like different L3 sequencer deployments. And then right now we just show you, the URLs can be exposed at, and you can access the deployments logs. And then you can configure. So the plan is to allow configuring with the deployment some parameters like the CPU memory will have storage here as well, and then the version of the sequencer that you want to deploy. And then, yeah, so it's be quite simple without any, we'll have like ownership authentication, and authorization for the sequencer and the ability to upgrade the images initially, but we won't have like tokens for permission access to like if you look at like the things that Alchemy supports on RPC endpoints, like around like queries permissions and tokens and stuff like that, we won't have that initially. So it'll be quite simple, but I think like will be a nice way for people to easily spin up Madara sequences, to run tests against them in the shared context. Also, obviously, won't support checkpointing to layer 2 or layer 1 initially, or proving. All of these things are still a work in progress, and will take a little bit of time. But yeah, I think it'll be a great place to make Madara available to specifically for games building on top of Madara. I mean Dojo in the short term. And I think in the ecosystem with people that are interested in building on top of it, like I know with Kakarot, for example, if you guys are interested in having us host a managed instance for you guys, we can do that as well.
Thank you very much. This is amazing, very exciting. Okay. Yeah, Matthias, please, you want to do your announcement?
Yes. So we just announced basically a hackathon. So a 2 weeks virtual hackathon that will happen in June from the 12th of June to the 25th of June. So yeah, it will be an amazing hackathon. We have a lot of prizes. There will be people from Dojo, Starknet, so there will be a Madara track as well. So if you want to build something related to basically anything, just come. So the registration will happen on Monday, and yeah, we just announced it. So excited to see you all there, especially to build yeah, many things. So if you're here, it will be about Madara or Dojo, but yeah, feel free to explore. Yeah,
Yes,
and feel free to give ideas, yeah, for the hackathon. That's very important. The more ideas you give, the better. Yeah, and you will see everything on the platform we'll be using. You have all the ideas, the themes, the tracks, and everything. So yeah, excited for this.
Yes, definitely. So we have put some few ideas, like for example, direct and native compatibility with Ethereum addresses in Madara, using Eigen DA for data availability. Louis wants to push again this crazy idea of sovereign Bitcoin rollup using ordinals directly in Madara. Elias created something to basically deploy Kakarot testnet using Madara and deploy some EVM smart contracts, support of Celestia. So again, yeah, feel free to submit any crazy idea. Yeah, don't limit yourself. We really want crazy stuff to be built on top of Madara, and yeah, I think it will be a very cool event. It will be 2 weeks long, right?
Yeah, it will be 2 weeks in remote, so you can participate from anywhere. And yeah, we'll have a big ceremony on the 12th. There will be a lot of workshops from both us at Madara, people from Dojo as well. from all the ecosystem. So you'll also be able to learn a lot, I think.
Very cool. Okay.
Can we have the link in order to suggest new hackathon?
Yes.
New ideas?
New idea? Yeah.
Yeah, it's in the
So this
GitHub
is-
discussions of Madara. Yeah, and for other ideas coming soon.
Okay. Awesome. Yeah, Ben, if you can give if you can do the deep dive on the Starknet and Invoke transaction, and yeah.
Yep. Can you guys see my screen?
Yes, we can.
Okay.
Maybe you
so that's-
can put the bigger font. Yeah. Yeah. Thank you.
Oh, cool. So this is the bulk of it here in client RPC lib. So yeah, for the most part, we know how to expose the interface in RPC core. So I'm just going to go into this function. We're using Starknet RS types, which simplify a lot of things. So broadcasted invoke transaction and invoke transaction result are both from Starknet RS code gen. Just simplifies the interface to and from for request and response. We're getting the best block hash because we're only adding an invoke transaction to the head of the chain. This is a little bit unfortunate. I'm not sure if you guys have been following it, but on 441 here, we have a to invoke transaction method here. So not the most idiomatic Rust here. What we would love is an into or a from. The reason that this is the case right now is that Starknet providers doesn't expose a no STD feature. So if we did want to have that the try from or the try into, we would want to put it in the primitives type, which needs a no STD compat. So right now it's just a util function that's exposed here. But I think there's some plans to maybe fix that in the future. But yeah, basically we're going from the Starknet RS type to the transaction type that the runtime expects. Here, this is kind of what we mentioned earlier. So when we get these runtime APIs, it doesn't give us the ability to persist that information. So we actually have to build and encode the extrinsic by hand. That's this right here. So 444 to 455. We're building the extrinsic by hand. And then we also had to expose the transaction pool to submit the extrinsic to the runtime. So here we're building and encoding the extrinsic, and then we're submitting it to the pool here. Yeah, that's the most of it. Some of the return types from the runtime we talked about is the same as what Greg mentioned. So when we do this invoke into transaction, we actually calculate that transaction hash internally. And so then we can, if everything was submitted successfully, we can just return that transaction hash here. So I'll go through a quick demo of what this looks like. Here's the HURL for it. So we have a max fee that right now, since we don't have an estimate fee endpoint, it's just, kind of an arbitrary value above what it's going to cost to execute this transaction. The version is one. The test contract or the simple account contract that we're doing does not have a signature check, so we can leave this blank. And by default, it's not, it's 0. So the sender address is this simple contract, simple account contract in the resources files. And then the call data is that we're going to be calling the test account, which I'll show you guys in a second. The selector that we're choosing is what selector is it? Test. Where is it? Okay, test storage var is the selector we're calling. And there's no input to the selector, so 0. What do we want to see that make sure that this value was written? We're gonna check that actual key in the storage layout. So at this same contract, we're gonna check the storage key to make sure that it was changed to 39. One sec. All right, so we will start Madara down here. We will run our add invoke transaction, so we get the transaction hash back. So whenever we expose the get transaction endpoint, we'll be able to query and see the transaction receipt details. So then we'll get the storage, and the storage is 39. Any questions?
Okay, very cool.
Awesome.
Yeah, that's very cool. Yeah, and that means that we'll be able to start integrating with existing tooling. So yes, we can try soon to deploy existing smart contracts. No, I was going to say we can start deploying Dojo contracts, but no, we need support to do.
Can deploy a Uniswap.
We can deploy Uniswap and do a first, a Madara swap and try to, that will be a good start indeed.
It's always the starting
yeah,
for
it's
every
always the start.
blockchain.
Yeah. Okay. We can try to do that. That's actually can be good first issues. I mean, for people to jump in and fork
totally.
front end and Cairo 0 swap contracts and deploy Madara and create the scripts to deploy that. And ideally, we can even integrate that in end-to-end test of Madara to deploy an actual swap contracts and integrate that in the end-to-end tests. So by the way, I'm trying to we want to speed up the time needed to run the CI workflows. So we reached out to GitHub to have more powerful runners, but it's been more than a month now, and we don't have any news on that. So we will try to set up self-hosted runners. So I created an AWS machine. So the connection with the GitHub runner mechanism works, but for some reason, the CI does not pass. So there were some issues with environment variables and the path being fucked up by, I think it is because of the actions, the task that enable you to clone the repo. And after that, the path is invalid. So I tried to force it in the workflow itself, but it did not work. I will show you. It will be easier. Yes. So this for some reason after this action, the path is invalid. So then I try to force to source it again, and then the Rust installation works, but then there is some issues with LLVM code for some reason. Anyway, Ben, if you can have a look at that, I think it can be very cool because it will speed up the whole development flow. So it will be very cool. The version of Linux I'm using for this self-hosted runner. Okay, let me check quickly. GitHub runner. Okay. So this is the version I'm using. So it's an AWS machine. And and this is the service file for the runner. And it is connected to GitHub and it gets a job, but they are failing because of different reasons. Anyway, then we'll have a look at that. To give an update on the roadmap and the next big important milestones. So the first one is obviously to finish and complete the implementation of all the RPC endpoints. And then we can start integrating with other projects, start deploying actual contracts, like we said. So we can start right now with Cairo 0 contract, and then once we have support of Cairo 1, we can start deploying Dojo based smart contracts and games on Madara. Yeah, it would be cool to have some people trying to start deploying Cairo 0 contract on Madara, like we said, a swap or something like that. We'll create some issues, and I will flag them as good first issues. Then once we have that, there is another track, which is the testnet. So the idea will be to have a testnet with 2 or 3 nodes and start having a long-living testnet with the latest version of Madara. So I will check and sync with Terrence. So I will run a node on our AWS infrastructure, and Terrence has already some nodes running. But in order to make them compatible, we will need to do like create some node keys and generate a chain spec, or we can go with a local Genesis config and use hard-coded keys and make sure we don't use the same keys, and then it will work. But I think it will be good to start doing what we will do in a real production context. So, and I think it can be a good opportunity, for example, to do it during a community call, do the whole ceremony where all nodes providers, all sequencers will generate their keys, and then how we can create the Genesis config and the chain spec using substrate commands and whatnot. I think this can be very interesting for people. And I would like to involve the community in this process. So we'll think about how to do it concretely. And the first test with a few committee, and then once we are used to the process, we can try to do it live on the community call, and people can eventually do it live and run their own Madara instance, and we all connect together on the chain spec. I think this can be very cool. Then there is also the hackathon in a few weeks. Hopefully we will see some very cool features implemented on top of Madara. Another important big track will be performance. So we have been focused on the RPC. So for the moment, we haven't continued to implement the benchmarks and whatnot. And also one blocker was the time needed for the CIs. This is also why it's important to have those bigger machines so that we can integrate running the benchmark directly on the CI after each merge. It will be better to have a good view on the performance overhead after each pull request, and even potentially block some PRs if the overhead is more than X%, for example, something like that. Because, for example, we did the latest benchmark 2 or 3 weeks ago, and we had very good results. The last benchmark was 250 TPS, and we tried with even 100 millisecond block time. So, but now 3 weeks later, I don't know where we are at. So we have merged a bunch of PRs and whatnot, and it's pretty bad that we don't have a clearer view of the benchmark of the latest version. And to fix that, we need to have powerful machines to run the CI workflow. In terms of next steps, also one important milestone will be Starknet CC. So it will be in July 21st. We want to do something big with Madara and Dojo. Eventually do something on the main stage and do a big demo with a Dojo-based game running on the Madara testnet, and display the game on the screen and display the TPS. And even it would be amazing if people in the room could connect live, flashing a QR code and play to the on-chain game directly. So that can be a very powerful showcase of Madara, Dojo, and the Starknet stack in general. And yeah, then we will have we will need to work a lot on performance optimizations, which will be an important thing to do. And then there will be also, parallel to that, there is an important track, which is the compatibility with the public Starknet. So there are both some investigation about future features of Starknet, like the decentralization, like Timothée said, this is why we are experimenting with Tendermint. There are also more concrete actions we need to do. For example, let's say at some point we decide that we want to use Madara for the public Starknet, we will need to be able to start from an existing state. So that means that we will need to have some kind of a way to start with an existing state, either by creating a genesis with a big state hard-coded in the genesis, or to think about different mechanisms on how we can do that. An important thing, if we want to go to that direction, will be to make sure that if we wanted to have some client diversity, it would be feasible and not so hard to have Madara plus other implementation on the public Starknet. So for that, we will need to deep dive on how Substrate works under the hood on the P2P level and whatnot, and see if it is easy to implement.
There's also Starknet in Rust. At some point, when Starknet in Rust will be ready, might want to add that.
Yes, exactly. Yeah, Starknet in Rust, and see if we can. And another thing we need to do is generally think about the modularity and the generalization of some components. Starknet in Rust is a good example. We would want to let the possibility of projects to choose between the Bloatifier and Starknet in Rust easily, even switching live from one to another if needed. And then, in general, make sure that projects can configure and have a modular stack. Yes. And another important part, obviously, if you want to have something real, we need also the settlement and the state updates and whatnot. So we have some discussion with the engineering team in Starkware on how to do that. Basically, it's very likely that, on the public Starknet, you have the sequencer, you have the prover, but in between there is a service that is currently in Python, and that takes the block from the sequencer and do some logic and then submit that to Sharp, is shared prover. And this component will be re-implemented in Rust, and for the 0.12 stack for the public Starknet. And the good thing is that this component will be agnostic to the implementation of the sequencer. So in theory, we will be able to use it from Madara as well. But then we need to think about how we can have different kind of data availability layer, because this component won't be generic enough to have different kind of data availability layers. So anyway, just this is an important track we haven't started yet, but this will be obviously very important for projects to use it in production. Yes, those are the main. Those are the main tracks. So obviously there are plenty of work to do, and that's why we need to onboard more and more contributors. And I'm very happy that the project is getting a lot of traction and that we have more and more people working together on it. That's it on my side. If anyone wants to add something or ask a question or general comments, feel free to jump in.
Yeah, no, we just need also to add Explorer, Indexer, but all of this, it will be fairly easy if we're fully compatible with Starknet, but still.
Yes.
Yeah, we're also investigating with Kazar Labs the Starknet full node. So that will be interesting. It's basically possible to create a Starknet full node that syncs in peer-to-peer compared to Pathfinder, Papyrus that do not. So there's this, and many other things. We could go for hours.
Yes. Okay. Okay. Cool. Then I think we can stop there. I will stop the record.